thank you very much for asking me here today. So my name's Bleakley. I'll give you a bit of background. Basically, I've been doing model-based systems engineering for nearly 30 years. When I started doing it, I didn't know it wasn't called model-based systems engineering. I'm basically a mechanical engineer and I wanted to build robots. And the robots I built, I couldn't understand them. So I started building models and simulating them and doing similar stuff to what these guys were doing. Using the models for things like fault tree analysis, specifying software, and also for auctioneering trade studies. Okay, and that led me into 20 odd years of working with aerospace and defence model-based systems engineering. So a lot of my background is UML, SysML based stuff. Worked with people like JLR, Daimler, Bosch, Lockheed, pretty much most of the aerospace and defence companies around, among others. Whatever. 2 years ago, I left to join. I was working in IBM and I was product manager for Rhapsody then. 2 years ago, I left to join Costain, which was a very, very big shift in terms of where they are with respect to their digital journey and what they think about model-based systems engineering. But it has helped that I think of MBSE as being quite a wide church. It's not just SysML and UML. It's about using the models to actually develop whatever it is. It's develop products, whether they're railways, whether they're cars, whether they're planes. Okay, so it's a wider stretch. So Costain, who are we? We're quite an old company, 150 years. We started out as a painter and decorators, believe it or not. But basically, we're pretty much all over the country, 4,000 employees. But basically what we do, it's not just about going out, digging holes and filling them up. We manage the going out, digging holes and filling them up. Okay, so we act as project management, but within that project management type thing, what we do is we're trying to digitize that aspect. And part of it is about developing digital solutions to actually cover the life cycle of these projects and to actually help how we deliver them. Basically, you can see we work with all sorts of people. It just covers everything. So at the moment, I'm actually working on HS2 as part of it, and some of the things I'll be talking about will cover that. But another project that I worked on when I first joined was SPA, which is basically a pipeline from Hull all the way down to Essex to Colchester. And that's meant to be delivering water all across Southeast Anglia because it's really dry. But again, that's been really interesting. So, said I am MBSE, systems engineering. It's not just about the software, it's about everything that goes with it. That's starting to be realised within infrastructure. Okay, they're not very good at it at the moment. And this was a infographic that came out a couple of years ago from Institute of Civil Engineers. It basically works out a set of principles to improve systems-based approach. They call it systems engineering in infrastructure. We call it systems-based approach because they don't quite get that. Okay, they talk about systems thinking a lot without really understanding what it is. But the interesting ones that come from this is the ones I really like are Close the Gap, which is basically looking at other bits of technology from other industries. So we're starting to see a lot more people come from MDENet automotive within infrastructure, civil engineering space to help them with their systems engineering. B-cycle, they like it, but they don't understand it. Data always a project. They talk about digital twins a lot without really knowing what they are. But certainly this collaboration and data is the key to making everything work. And systems engineering is not just about the models, it's how you govern those models, how you develop them and the tool chains that support them. And I think it's the data one, but yeah, they're the three that I normally pick up on when I'm showing this slide. But it's data, taking things from other industries and applying the V process are the three main ones that I work with on this. But trying to push all of those within infrastructure delivery. So I don't know whether any of you have come across John Holt, Technical Director of INCOSI, International Council of Systems Engineers, but I've known him for a very long time. His company came up with this idea for MBSE on the slide. It's a very quick way to describe it. When we talk about models, you're normally seeing them as, well, modelling tools support proper modelling, okay? They're not Visio. So you're normally looking at a model which is part of a system. It gets reflected in part of a view that's defined by a capture onto diagrams, and it's got a notation behind it, which is all the sorts of things that we talked about. That gives it its formalism, okay? And it's about connecting, making sure those are connected together and not Visio diagrams, which is where a lot of stuff is coming from still. On the other side, which is just as important, so this is sort of based around 42010, very basic idea, but the viewpoint defines the views, based upon a framework, and it's about process as well. It's about how you manage that process to deliver the models, which is what Rutger and Mikhail have been talking about as well, except they've been taking it to the test side, the V&V side. And underneath it sits an ontology. But when we get down to this, it comes down to people, process, tools, and how they come together, really. Whatever domain that we're working on, whether it's just talking about software or much bigger things, it still comes down to those basics, from what I can see. And that's what I've been doing about. So when we look at infrastructure, it is MBSE, but not as you know it, okay? Literally, they have something called the Building Information Model, which is their underlying ontology, okay? So AADL is, if I remember right, it's the Aerospace Architecture Description Language. That's effectively their description language for that they used in aerospace. And I remember coming across that about 15 years ago. I think what they use in infrastructure is BIM as opposed to SysML. Building Information Model, it's basically 3D CAD with a lot of extra metadata that's tagged onto the side or underneath it with a set of basic ontology that sits underneath that. That's the simplest way of describing it. But once you've got that, you can really start to do some cool stuff with it. So you've got things like 4D, 5D BIM. 4D BIM is where you start to tie it in with project plans, and you can start to see how a project is built over the time. So you tie in project or layers of the CAD drawings into the project schedule, and you can start to animate it. And that's basically what this link was meant to be, but I don't think it will work on this somehow. Other thing is when you start doing 5D, which is the next thing, you start to put cost analysis on it, and it implies a full collaboration model and simulation. This is all very nice. Where we are at the moment, we're just about doing 3D plus a bit of 4D. What we really want to do is get to this 6D, all as built building information on the ground. I want to see the models being used to actually check what's being built on the ground. Okay, I wish we were there. It ties in with graphical information systems, so GPS mapping of all points. It ties into data models because there's an ontology that sits underneath it, various frameworks, asset information models, and integrated tool chains. And it is systems engineering because we do have requirements mapped to compliance. Okay, they're at a very high level, but there's standards that go all the way through this that we need to comply to. So we've got to have that as part of our tool chain. They work in terms of work breakdown structures, but these are based upon the concrete assets. Okay, the reason why they don't use MBA, they don't use SysML and UML is literally civil engineers cannot think abstractly. They literally think in concrete. Literally. So when you start talking about this to them, like the abstractions of a block or a class, it's just like going and interfaces and ports. But it does lead on to things like the structures that they do have, they've started to see they need to do dependency analysis about the program and stuff with it. They are starting to do optioneering. So one of the interesting things that we see at the end of this is where we started to tie the BIM models into carbon libraries and starting to model for net zero, which is quite an interesting way to do it. And it does need a stronger governance process, which they're not used to. So this is typically what we see for, well, this is part of their, what we call technical assurance, is the VMV part. So in this instance, they've got work packages indoors that come from the supplier. They get broken down into, this is us, so this is, say, HS2. That is HS2, this is the delivery, which is what I'm working on, which is SCS. So you get high level sets of requirements at asset level, broken down into work packages. And then they developed what's called a VVM, which is a validation verification matrix, which is tied to a bunch of evidence, which is held in another tool called AssetWise, and another doors module called, well, user aids, which is undertakings and assurances. It's basically all the guarantees that you don't make too much noise at a certain time. Okay, and you're going to turn off your machines in X. But what is really interesting about this is that they have their models, but their models are very upfront centric. They basically live on ProjectWise, which is their modeling tool for BIM, and then they get generated as PDFs. Okay, and then it becomes very data centric, document centric and data centric, and then it goes across a tool architecture that's like that. Okay, and that's simple compared to the real one because I'm not allowed to show you that one. But basically, the tool architecture that we're dealing with is very complicated. It does a load of stuff outside of the design. Okay, it's not just about managing the design; it's about managing the design plus all the verification activities that come off the back of it. It's about how does that fit in with the site diaries of people going out to work. How does it fit in with material compliance and feed into it? So model-based systems engineering is more than just the models. It's about how we actually create. To my mind, the thing I found really interesting going from just being about the models to understanding how it fits together with the life cycle. This is over my career. How does it fit with requirements, the models, the test, the formal verification, because I've been involved with all of the stuff that we talked about earlier. So understanding that if you haven't got this infrastructure in place, you can't do any of it properly. And so that's what's driven me to sort of part of this point in my career. So that just gives you a hint of the tools. So ProjectWise Rivet, they do the CAD doing stuff, SAP, which does overall cost management, GIS for the, or ArcGIS for the graphical information systems, Primavera, which is project planning, Doors, Jira for requirements, some task management. All of these tools have their own interfaces. They don't really talk. You've got to build all those together. What they tend to do is basically export a load of stuff as CSVs, and then you run Power BI on it. SharePoint is our big database. Okay, I wish it was better. So we end up with a lot of proprietary point-to-point integrations with a lot of data. And really, what I've learned, because I've seen it with companies like Bosch and Daimler, British Aerospace, they spend as much time engineering these support systems as the things being developed. And that's really one of the key things around when you start to take model-based systems engineering out to industry. Okay? Academia, it's easy. And I say that with being an academic, because you can do anything you like. But when you start to really play with this, you start to see some of the complexities of the real world. The other big thing is around the process governance. And to some extent, we're trying to manage that through modeling as well. We've got model-based systems engineering governance that we're building. So we're understanding our processes, actually modeling those processes and putting them out on the websites so that people have a common understanding of it. So you identify the tasks, you associate roles with tasks, understand what the word products are, understand how they link together to create processes. And this isn't just thinking about it as a single set of processes, this is a linked set of processes. So we're also doing it on this because at the moment they do this on Visio. They have hundreds of process documents that are all Visio. And the only way that it works is because it's held in people's heads, okay? And it's not modeled properly. I mean, one of the things I always say, the model is your memory, and it goes back to what Mikhail was saying about the ambiguity. The model helps you find ambiguity. It really helps you to understand all the issues with what those requirements were. And that's basically what your designer was finding, wasn't it?
Yeah.
Yeah. And why the architects said, well, your requirements weren't that good. It's easy to write requirements. It's even easier to write really bad requirements. So really it's also separate about what from how. People think too much about the implementation rather than they do about what it's actually about delivering. I think that's it. So optioneering, so systems design for X is one of the other things. So reduce carbon, we applied some of this to a model. So you can take fill quantities, tie it into the bin model, tie it into a cost estimation, give it a carbon inventory, and then you can work out integrated cost and carbon models. And this is one of the things that we've done. I don't think they're on the slides after that one. So in summary, we're trying to apply MBSE by stealth. We use the language of infrastructure to develop it, but we implement MBSE principles and practices without them trying to be aware of it, okay? Because in much the same way that class was not accepted by the systems engineering community when they started using UML and it had to be changed to block, I spend half my time changing my language to fit whatever domain I'm working in, and that's really key. The key to it, or what they want to be able to do really, is measure progress. They are very keen on doing what you were saying in the code world. I want code, I want code, I want code in infrastructure, what they want. I want that hole dug and I want it filled with concrete now. Okay, they're not really thinking about the bigger picture for it. It's about left shifting, pushing that side forward and trying to make them understand if they took a little time to think about it, they could do it better. And that's about where you need to want to improve efficiency. And the quality management stuff that we've done has already, we think on one process saved like something like £32 million, just because it's reducing the life cycle. So that was a very quick run through of how we're trying to apply MBSE in infrastructure. And I know it's a bit different to the level that you're talking about here, but I've done a lot of what you guys are talking about as well. So thank you.